The question talks about f of x, which is equal to 1 by x, and this function is mapping non-zero real number to non-zero real number. So we can see that, show that the function f mapping non-zero real number to non-zero real number defined by f of x is equal to 1 by x, we have to show that it is 1, 1 and onto. Now, first thing first, let's look at the graph. So we have the function 1 by x being plotted over here, and this is the graph. I'm going to zoom in a bit. I think a bit more will help. Yeah, this is okay. Let's understand this graph. What is that we're looking at? So first thing first, we need to understand that this line, that is the y-axis, represents your input or the output set. This is our output set. That is your correct codomain. While this is your domain. That is nothing but your input. This is the very first thing that we need to understand. The question is it 1, 1 and onto? In a graph, the way we can find 1, 1 is just draw a line parallel to x-axis. Okay, let me do this over here. Now, if I take this line across throughout in this manner, if at any point this line is crossing the function at two different places. For example, here it is crossing this particular red dot and nowhere else. This blue line is the function. This red line is not crossing the function other than at one particular point in this graph, right? Let me take a contradictory example. This will help us understand this. In this graph, if I happen to draw a horizontal line, clearly this horizontal line, for example, there are so many horizontal lines over here, like across 8. It's crossing two different points of this function. While over here, if you look at this graph, all of these lines, to be honest, other than this red line also, this black line also, you can see that we are crossing at every horizontal line, we're crossing the function at only one point. Because of this, we can tell this function is onto, 1, 1. 1, 1 is a scenario wherein we have only one output, or I can put it in this way, for every output there is a unique input. That is, only one input will point to that output. That's 1, 1, right? So all of this is again written and defined over here. So you guys have to revise this. So this is happening over here. So this is 1, 1. Is it onto? Yes, it is onto as well. Why? If you look at this graph again, back to this graph, we can see that we have quite a few possible outputs. Let me kind of zoom in again. If I further zoom in, we can see that this graph, it's very close to this y-axis, and then it is almost parallel to x-axis. So other than 0, which we have excluded, by the way, remember, right? It is a set of all non-zero real numbers. We have excluded that. We can see that we have all the possible answers. Like if I keep varying this, so we can see that we can get all the possible output values. So every output value other than 0 is part of the what? Yes, every element in the codomain is part of the range, right? Range is nothing but set of values which are part of your output. So no element in the codomain is missing. And so it is onto, also known as surjective. Basically, it's a bijective for the defined set. This function is bijective for defined set. Okay, so you guys, main thing that you guys have to keep in mind is, when you read the graph, if you draw an horizontal line, if the graph at nowhere cuts the function at two different places, it's onto. sorry, 1 1. I get confused. Not confused, I'm just repeating without thinking. Yeah. So this is 1 1. Let me write this and put it across. So first thing first, we're talking about 1 1. Now, the funda that we are going to make use of over here is proof by contradiction. That is, we're going to take it as f of x as many to 1. Not 1 1. We'll take it as many to 1. That is, we're going to consider, I'll write it over here. Consider m comma n belonging to R star, right? Such that f of m is equal to f of n. What does it actually mean? So what we are looking at here is, we're considering two different inputs, and we are telling that they are pointing to same output. OP stands for output. Okay, so we have the same output. Which scenario is this? We can see that it's many to 1. More than one single input pointing to the same output is many to 1. Now, but what is f of m? F of m is 1 by x. In this case, sorry, 1 by m. What is f of n? It is 1 by n. When we simplify this further, what will we get? So m is equal to n, right? All in all, what can we tell? From this we can tell f of x is 1 1. This thing points out that no is the same input value. Again, let me explain. So we are making use of proof by contradiction. That is, we are considering f of x as many to 1. So we are telling m and n, which are two different outputs, is pointing to the same output. Two different input are pointing to the same output. When we solve this, we came to a conclusion that no, it's the same input, right? M is equal to n means what? They are the same. And so we ended up with talking about f of x as 1 1. Okay, so f of x is 1 1. Now, we have to talk about onto. How do you prove onto? The funda over here is that we need an expression for x. What does that mean? We need to express x in terms of m or anything else. Let me show that. So we will consider m that belongs to set of non-zero real number representing arbitrary value at the codomain. Okay, so what are we telling is, we're representing m, or we're taking m to represent all of these values, all of the possible output values. Now we can write f of x as m, because that's what we are talking about. So what is f of x? F of x is 1 by x, which is equal to m, and this can be re-expressed as x is equal to 1 by m. What does it mean? X is equal to 1 by m represents an equation which is giving us all the possible values for or expression for x. So let me put it in this way. as m belongs to r star, that is non-zero real number, and x also belongs to r star. Thus, for any value at codomain, we have a value at the domain which is given by x is equal to 1 by m, such that f of 1 by m is equal to 1 divided by 1 by m is equal to m. That is, for any output value m, I have 1 by m at the input value, from which I can get m. And with this, I can tell that f of x is onto. That's what onto should mean. Onto means that you give me any output value or any value from the codomain, I can give an input value which fetches that. Right? That's the whole idea of onto. Every possible output value is reached by at least one input value. That's what onto means. And we expressed, or we can express the answer, or we can write the answer in this manner. That's it. For every possible question wherein you have to show something is true, you just have to write it in this manner, as simple as that. Okay, so this is your answer in entirety. Now, there is second part of this question. Is the result true if the domain, that is the input set, is replaced by n? So it being a non-zero real number to natural number is what we are looking at, with the codomain being the same as non-zero real number. Right? So this is your question basically. Now, let me explain it this way. Say I want an output of, let me go to the graph. I want an output of 2. Okay, I'm looking at an output of 2. So what should be the input? Oh, sorry, I'm looking at input. I want an output of 2. 2 is over here. So this is your output, minus 2 actually. I'm looking at an output of minus 2. Remember, y-axis represents minus 2. So that is basically minus 2 is the output. And if I follow this, the input has to be minus half. Remember, the output has all the real numbers, while the input does not have all the real numbers. Input is replaced with natural numbers. So what can we tell? Well, for an element, or let me tell it this way, minus 2 which belongs to codomain, we need minus half at domain as its pre-image. But minus half is not part of your, right? It's not part of your natural number. So from this I can infer that the result changes. It's not onto anymore, right? So f of x is not onto when you have function natural number, when it's mapping natural number to non-zero real number. Okay, so I hope you guys had a decent idea now. You have a decent idea now. So 1 is quite simple. It's proof by contradiction. So it's very simple. onto the funda is you need an expression for x, and you basically have to write this in this manner and you're done. If you don't understand onto as of now, understand that we just have to express x in terms of m, and you are pretty much done. If you have to prove something is wrong, you just talk about this. Pick up a output value. So we have to figure out what should be the input value. In this case, it's -12. Okay, it's a simple substitution and working out. So we'll get an expression for, basically it's nothing but expression for x. So m is -2, so x will be -12. Anyways, as and when we do more problems, we'll get to understand this. So all of this is quite simple. Just that the writing and the language makes it complicated. That's it. Conceptually, it's very simple.